All right, we're going to do 16 through 20 on the final exam review. So we have another 30, 60, 90 triangle. I say another because the last video we had a few. 90 degrees, 30 degrees, this must be 60 by triangle sum theorem. There are 3 steps I taught you. First step is to label the ratio of the sides. The short leg is n, the long leg is n times the square root of 3, and the hypotenuse is 2 times n. Step 2, notice I put an equal sign with each of those with whatever was there. Step 2 is to solve the equation we created with the equal sign and the given information. Got to solve for n. So I think I'm going to rewrite it over here. N root 3 is equal to 12. We'll divide out that root 3. That becomes a 1, leaves me with n. We have 12 over the square root of 3, which is a problem because we can't leave the denominator with a radical. So we multiply by root 3 over root 3. That gives us 12 times the square root of 3 over square root 3 times square root 3 is square root of 9, which is 3. We're not done yet, though, because the 12 and the 3 can reduce. We can't reduce the 3 with this because that's not a 3. It's a square root of 3, which is 1 point whatever. But the 12 and the 3 can reduce. 3 goes in there once, and there 4 times. So our n value becomes 4 times the square root of 3. Our denominator's 1. We don't need it anymore. Found it. Step 2 was a bit long. Sometimes it's quick and easy. Sometimes it's all involved like that. Step 4 is to take that n value and plug it in to the other sides and solve if necessary. In this case, y is the n value. So y is 4 times the square root of 3. And x is 2 times the n value. The n value is 4 times the square root of 3. So now we have a little simplifying to do. The 2 times 4, of course, is 8, so x is 8 times the square root of 3. All right? Number 17. Solve for the variables. There's only one. Okay, there's only one. Since they give us an angle and a side length, and it's a right triangle, this is an indication that it's a right triangle trigonometry problem. We could use SOHCAHTOA. And we start with our reference angle because we've got to figure out which trig function are we going to use, sine, cosine, or tangent. So we need to know, do we have opposite hypotenuse? Do we have adjacent hypotenuse or opposite adjacent? So we start at the reference angle and label what is the relationship between the variable and the angle and the given and the angle. And the given 14 is right next to the angle. We call that adjacent. The x is also next to it, but we can't call that adjacent because it's already the hypotenuse. So we've got an a and an h. We look up here. That means we're going to use cosine. Trig function, cosine. Always next to the trig function, we put the angle. 52 degrees is equal to the ratio. You can go back to SOHCAHTOA for the ratio. It's adjacent on top, hypotenuse on bottom. Adjacent numerator, hypotenuse denominator. And I always taught you every single time multiply by the denominator. It's a little bit kind of not helpful at first because we want to get the variable by itself, and that did not do the job. So we still have some work to do to get the variable by itself. To do that, we can divide out the cosine of 52 because it's being multiplied by x. Dividing out gives us a 1 times x. Working over here, it's not here, is x. And our exact answer is 14 over the cosine of 52 degrees. That's exact. Pretty sure the test is going to ask you for an estimate. So we've got to go to our calculator for the estimate. Let's see. Check the mode. Make sure you're in degrees. We are in degrees. All good. And then we go 14 divided by cosine 52. Enter, and we get 22.74-ish. 22.74 is the estimate. Moving on, 18. Solve the variables. There's only one again. Same problem, SOHCAHTOA is a useful tool. Start with the reference angle. We have opposite and hypotenuse. That tells us sine is the trig function. Every single time we set up the trig function next to the angle, multiplied by the angle, sine angle equals ratio. I should say trig function angle equals ratio. The ratio is opposite over hypotenuse, 13. Well, we need to mix this up a little better. Again, that's just like the last one. We're going to multiply by that x, but in the end, it's going to end up as a division problem. So we could jump straight to it. We know it's going to be x equals that 13 over the sine of 69. Since we just did it, same type of problem, we know it's going to end up division. That's exact. Our calculator will give us the estimate. 13 divided by sine of 69 is about 13.92. X is about 13.92. Two more. We got this. That's 18. Number 19. Another trig. Let's hope it's not another division, just to mix it up a little. SOHCAHTOA. My something's growling in the background. We have opposite. Ooh, this is fun. Adjacent. That's tangent. Opposite adjacent. Trig function is tangent times the angle equals the ratio. Good. Opposite variable on top over adjacent. So this one's a little different. We're going to multiply by the denominator, and then we're kind of home free because we have x by itself. This is the exact answer, 22 degrees, exactly. And then go to our calculator for an estimate. Squeeze this all in. I don't know why it's showing up funny like that. Well, we can't see it. Is this helping? Kind of. Oh, that helped a lot. Now I'm in the dark. That's fine. 19 times tangent of 22. We get 7.68. 7.68. I'm just in the dark. I can't take it. I'm going to make it a little brighter for me. Okay, that is number 19. Last one. And we're not quite, but close to ready for the final. This one's tough. I'm going to want a diagram for this because this is like information, but I've got to see what does it mean. Great, tangent of some angle is 20 over 21. What does that mean? Well, we definitely have a ratio. We have tangent angle equals ratio. We're still going to use that SOHCAHTOA. And I'm going to draw a diagram because this has got to be a right triangle. The reference angle can never be the 90-degree angle. It's one of the others. It doesn't matter which one you decide to label angle A. It doesn't matter. But what we know is tangent is opposite over adjacent. So this 21 is opposite. I'm sorry, the 20 is opposite. The 21 is adjacent. That angle A. So angle A is here. So opposite is over here. That's 20. Adjacent is right here. That's 21. Okay, now I have like some idea of what's happening here. My diagram helped me out. What we want to know is what is the sine of angle A. Well, back to SOHCAHTOA, sine is opposite over hypotenuse. So it's going to be opposite here, hypotenuse there. We already know opposite of A is 20, so that's definitely in the numerator. We need to know the hypotenuse. We'll call it H. I don't know what it is, so we're going to have to solve for the hypotenuse. It's a right triangle. We have two legs, need the hypotenuse. That is Pythagorean theorem. Leg squared plus leg squared equals the hypotenuse squared. We get 400 plus 441, I think. 21 squared. Yeah, 441 is the hypotenuse squared. This gives us 841 equals the hypotenuse squared. And then when we square root, we get the hypotenuse is, I think, 29. Square root of 841. Yep. is 29. Will calculator help? So we found that hypotenuse, and that's what we needed to finish off our ratio here, 29. So the sine of A is 20 over 29. Yay! We're pretty much ready, but check this out. There's a lot more on the final than just those 20 problems or problems like those 20. You need to know ways to prove congruency, like side, angle, side, angle. Let's see, you can't use angle, 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 right? You can use angle, angle, side. We can't use angle, side, side. There was also hypotenuse, leg. Is that all of them? Oh, no, that's not. We forgot side, side, side. So those are all the ways to prove congruency. Ways to prove similarity. Remember, angle, angle could do it, and side, angle, side could do it. I feel like I'm forgetting one. Why am I thinking? Angle side. Does angle side angle? I'm telling you, I'm gonna have to look that one up. I'm drawing a funny blank on it. I feel like yes, angle. I have to think about it. Angles. Yeah. Well, angle side angle would just by way of angle angle, right? If we have two angles, so that's kind of silly too. You don't need that because angle angle covers it. Anyway, you better look those up because I'm drawing a funny blank right now. The units. I'm sorry. Unit circle. The unit circle is math 3. The circle unit, the unit that we did on circles, that was the last one not too long ago. You got to review. There's a lot of circle problems. You need to know Pythagorean theorem, everything quadratic. It's a lot. So review it. Look for problems that we have done for all of those. Okay? Have a great day. You're going to do well.